Hello, good morning. In this today's lecture, we are going to study the preparation of the SiCl4 and discussing the structure of SiCl4. Today is too much cold. Silicon tetrachloride is prepared by the chlorination of the various silicon compound such as the ferrosilicon, silicon carbide, or the mixture of the silicon dioxide and the carbon. In the laboratory, SiCl4 can be prepared by reacting the silicon with chloride. Example is here: silicon react with the 2 molecule of chlorine, 2Cl2, gives the SiCl4 as a targeted molecule. If you study the structures and the hybridization of this silicon molecule, we find that the electronic configuration of silicon is 1s2, 2s2, 2p6, 3s2, 3p2. This is the electronic configuration. Means the valence shell electrons having the 2 electron of the s orbitals and 2 electron of the p orbitals. So 3s2 and the 3p2. These are the 2. In case of SiCl4, the ground state electronic configurations having the s electron in paired form and p electron is unpaired form. So for the making the unpaired electrons more, we excite this molecule, and in the excited state electronic configuration of the silicon having the 1 unpaired s electron and 4 unpaired p electrons. 4 unpaired p electrons. So now the SiCl4 is now ready, having the 4 unpaired electrons, can react with the 4 molecule of chlorine. We know that the electronic configuration of the chlorine having the 3 lone pair of electrons and 3 lone pair, 1 non-bonding pair. 1 single electron, means having the 7 electron in the valence shell. That 7 electrons are in that 1 electrons involved in the bonding, and chlorine also completed its octet. So in this way, chlorine formed 1 bond with the silicons, means 4 chlorine, 1 silicon, 4 covalent bond, get the product that is SiCl4. For the hybrid orbitals of the silicons overlap with the half filled 3p1 C plus of the 4 chloride atoms. Generally, SiCl4 is a tetrahedral with bond angle of the 109 degree. This is the bond angle of the SiCl4 molecules. Next is the structure. Structure represent the SiCl4. SiCl4 is a tetrahedral molecules. Occurrence and the extraction of the germanium. Next point is the occurrence and extraction of germanium. Germanium does not occur in the nature. It is rarely found in the traces. Germanium occur in the small quantity to minerals like argidolites, that is the 4Ag2S-GeS2. This mineral is mostly found in Germany. Next is the germanite 7GeS-FeS-GeS2. It is found in the South Africa. Next is the canfieldite 4Ag2S-Ge1Sn SC2. Next is the extraction of the germanium Ge formite minerals. Extraction of the metal from its mineral ores are involved 3 steps. One is the concentration, second one is the refining, and the third one is the reductions. So extraction of the germanium. Germanium is usually extracted from the oxydides or the germanoid ores. Extraction from the argidolite ores. The finally powdered dry ore is fused with the Na2CO3 and the sulfur. The fused mass is extracted with the water and treated with dilute H2SO4. Then filtered to remove the impurities like Es2, S3 and Sb2, S3. The filtrate containing the soluble germanite salt is treated with the excess of the HCl and saturates with the H2S to PPT, that is germanium as a Ge25S. This PPT is then washed and roasted with the HNO3 and ignited when the Ge2S is converted to the GeO2. Reduction of the GeO2 germanium. GeO2 is placed in the highly pure graphite crucibles and is reduced to Ge by the heating 600 degrees centigrade to 900 degrees centigrade in the presence of H2 gas. So the GeO2 plus 2H2 gives the Ge plus 2S2O. Next reaction is the GeO2, germanium dioxide, react with the two carbons, gives the Ge plus CO, carbon monoxide. Next is the extraction from germanite ores. Powder dried, heated at 350 degrees centigrade in the atom of the chlorine to obtain germanium as the GeCl4 along with the AsCl3, S2Cl2, which are separated by the fractional distillations. The GeCl2 is distilled over at 83 degrees centigrade. In the distilled GeCl4 is passed with the vigorous strings over the crushed ice. When GeCl2 gets hydrolyzed to GeO2, the hydrated GeO2 is saturated with the chlorine, distilled and hydrated with ice. White precipitate obtained on the drying and the ignition gives the GeO2, which on reduction with the S2 or carbon gives the germanium. Next is the preparation of the borax. The formula of the borax is Na2B4O7 dot 10H2O, 10 molecules of the crystallization. Borax can be obtained boric acid, that is Na2CO3 plus 4S3PO3 plus Na2CO3 gives the Na2B4O7 plus 6H2O. Borax can be obtained from Ca2B6O11 dot 5S2O plus 2Na2CO3 boil 2CaCO3 plus 2Na2BCO7 plus 2NaBO4 plus 5S2O. Borax is naturally as a tinkle and a suhagan. Next, the silicon and the germanium. Verifying techniques for the purification of the germanium and the silicons. Zone refining method in its simplest form involve the movement of the small molten reagent, that is zone, through a solid ingot mass of the last metals. Impurities are more soluble in the matter phase than in the solid phase. Germanium in gold has in place in the narrow boat is pulled through the tube furnace in which several normal zones are created as see as the mill's narrow portion of the ingot. Hot zones are usually created by the graphite ring heated by radio frequency inductions or by the direct current. At the ingot is pulled through the hot zone. The matrix zones pass through impurities continuously along the box from one end to the another end. So the friends, the diagrammatic representation remaining part we will discuss in the next lecture. Thank you.